Good morning. It's a pleasure to be here. Unfortunately, this title isn't rhetorical. We don't scientifically know where and when to control the vectors of leishmaniasis. I've chosen Brazil because I'm working there. It's one of my projects. A lot of leishmaniasis is in Brazil, but I could be talking about anywhere, including Europe. So at the moment, where and when are the vectors of leishmaniasis controlled? It's where there's enough of an outcry, where there's enough political will, enough finance, which is a very bad situation. Okay, so leishmaniasis, sandflies, phlebotomid sandflies, the females are the only known natural vectors. So most vectors are not domestic. So in textbooks, most experts, most meetings, they would say they can't be controlled because of this. They occur in a wide range of habitats, natural landscapes, both for zoonotic and for anthropogenic leishmaniasis. So, is it worth trying to control them? Now, the main initiative at the moment when it comes to leishmaniasis control, sandfly control, and the main thing that might motivate people in Brazil and worldwide is what's happening on the Indian subcontinent. So as you can see here, in 2005, these three governments got together. They're going to eliminate VL. It's a little bit behind, but it's really pretty much worked in Nepal and Bangladesh, and they're catching up in India. I'm sort of on the fringe of this, helping at the London School, and there's also a DFID project. So, starting off with visceral leishmaniasis, which the project in the work in India, in the Indian subcontinent, is focusing on. You see, it's a pretty widespread disease. The anthropogenic disease is in India and in East Africa, where it can be zoonotic, perhaps. Okay. Elsewhere, most of visceral leishmaniasis is caused by Leishmania infantum. This is a zoonotic disease. Classically, it's in Europe and Mediterranean region, where it's been exported, perhaps 500 years ago, to the Americas. In Europe, it's mainly a veterinary problem these days. So, in Brazil, for most of the time until perhaps the last 10 years, this is a typical sort of scene environment where you've got Leishmania infantum, Chagas, being transmitted from dogs to humans by sandflies, usually only one vector. There's quite a lot of control going on in Brazil. How successful it is another question entirely. So, what is the relevance of European control of this parasite to Brazil? In fact, partly because of confidentiality from veterinary companies, from big pharma, it's rather difficult to work on the transmission modeling of ZVL in Europe. This is a recent paper, and I was asked to do a research editorial for it, and this is one of the few papers that really challenges whether or not control, whether interventions are working. So there's not a great deal of help from Europe for Brazil. So more generally, what's happening with leishmaniasis? Integrated control. First question we always have to ask, are we really interested in controlling the persistence of transmission and establishment of new foci? Because in most parts of the world, people are content to do the first thing, just being interested in controlling disease progression, disease symptoms. Okay. So in the near future, there are vaccines. When it comes to human vaccines, these have been in development and almost there for decades now. Dog vaccines, far more promising. However, there are different vaccines being used in Brazil and in Europe, and it's not altogether clear whether they're actually going to provide protection or just reduce the number of symptoms. That's very much for the future. Currently, you've got case detection and drug treatment. This is the most important thing for canine leishmaniasis, human leishmaniasis. There's also reservoir culling. This is done a lot. A lot of dogs are culled in Brazil. How much effect this really has, again, very unclear. So we get to vector control. The accepted wisdom is that this is unlikely to work in isolation. You have to be part of integrated control. You've got widespread indoor residual spraying. This is wrongly spelled there, but it's used a lot in Brazil. It's used a lot in terms of responding. It reduces nuisance biting. Whether or not it actually reduces transmission is another thing. You can see insecticide-treated nets have been used on the Indian subcontinent, sugar baits with toxins, systemic insecticides in gerbil hosts, cattle, pheromone lures in Brazil, deltamethrin dog collars, Brazil and Europe, insecticide spot-ons, repellents. There's a whole host of things, but not much of it is being used routinely. Not much of it has really been shown to prevent transmission. Okay. My main take-home message is that we need far more modelling of transmission and interventions to see just which of these interventions could truly work. Some of this in the past, proof of principle, one study, an R0 approach. There are many other approaches. This was in southwest France. Okay, moving on to cutaneous leishmaniasis. The parasites causing visceral leishmaniasis can cause cutaneous, but usually most of it is elsewhere. You've got cutaneous leishmaniasis in Southeast Europe, in Asia, but also you've got a lot of cutaneous leishmaniasis in Brazil. So we're going to hear later about Leishmania tropica, how to control the vectors in the Middle East. That's a fairly simple situation. It's mainly anthropogenic. However, when you come to Brazil, you've got a lot of zoonotic cutaneous leishmaniasis. You've got Leishmania brasiliensis causing most of it, but there are 4 other species. The main reservoir hosts, you've got rodents, marsupials, monkeys, the domestic dog. Incriminated vectors, not just one vector as you have for Leishmania tropica in the old world, you have at least 10 species, including something called Leishmania intermedia. Okay, so I'm involved in a project that's been going for a couple of years. It's based in the Institute of Oswaldo Cruz in Rio de Janeiro. My collaborators are Elizabeth Rangel and Bruno Carvalho. This is a CNPq-funded project, and the idea is to map all Brazilian vectors. So this seems fairly basic work. We don't really know where the vectors, the incriminated or suspected vectors, actually occur. There are collaborators from all Brazilian institutes involved. They've got collections, etc. So, a bit of science, just to end up on. Of the 10 species that could be vectors of cutaneous leishmaniasis or are known to be vectors, one of them is Lutsamia intermedia. Now, until recently, intermedia included what are known to be 2 species these days, Lutsamia intermedia and Lutsamia nevi. So in this first approach, with all this distribution data we're getting from Brazil, we're producing ecological niche models to predict the full range that the flies could occupy. I must stress they're not occupying all that range at the moment, and these ecological niche models are based on climate variables and increasingly on land cover and land use variables. Then, in this one example, taking climate change scenarios, you then use those niche models to predict where the flies and transmission could be in the future. So here you've got a current prediction of where these flies are and could be. Here you've got 2 different climate change models. One, conservative modifications of human behavior, of industry. This one, a more extreme. And you can see for these two species, look to my intermedia sensu stricto, in the reddish, look to my nevi in the blue. The dark blue is where the two overlap at the moment and in the future. The take-home message is that both species are not expanding their range, not predicted to, with climate change. They're actually contracting their ranges. In the case of intermedia sensu stricto, it's really contracting its range and expanding nowhere, spreading nowhere. In the case of nevi, it's actually shifting its range further south, but overall, the amount of area available to it will be reduced. Of course, this is just the first stage of looking at how to control the transmission of this disease. You start off with where the flies are, where they're likely to be, then you go on to transmission modeling, looking at the densities, the biting rates of the flies, etc. Yeah? So I'll leave it there. That's it.